Hi, we're Team Suny Poly, Dr. Khalidi, and my colleagues at school, Ruthra and Michael, Mito, Axel, Hadi, and Faribors, and I'm Chris. So we went through and initially wanted to try and tackle all 6 tasks. Of course, by the time we got about to day 3, we realized that would not be the case. So we decided to take on a few, a smaller set of tasks. Task 6 we had practically gave up on just because we were going to try a different approach for orchestrating tasks 4 and 5 through a security setup. But nonetheless, I'll take us through 1, 2, 3, and 5 with what we had and some lessons learned at the end. So we were able to install the Helm charts and script the deployment of the 5G core functions. That ran us through step 4, as we have here. I actually went through and redeployed it so that I could get these artifacts. We had some problems where we actually didn't post everything in our chat, so I lost out on some good screenshots for some of this. But nonetheless, we did get Helm up and running. We did get the pods deployed. We were also able to confirm the SMF and SPGWU connectivity for the following step after that, 4.1, and we did get some good artifacts out of that as well. Beyond that, we moved to task 2. This was Wednesday. So we did spend the first 2 days on task 1. Wednesday, we moved to task 2. It's very easy to clone the Git repository, but nonetheless, we were able to clone the Git repository. We went through and were able to run the build script to build from the files. And then after a couple hiccups, we were able to deploy the charms. We and a few other people ended up with a strange version 1 of the Juju controller. So after we upgraded to version 2, we were able to get this taken care of for task 2 as well. Let's see here. After that, we were able to witness the successful initial deployment. This is, of course, without scaling because we did not get to that step yet. We're still on task 2. So you'll notice all the single digits in the scale column. But we were happy to witness the successful deployment. And at that point, we moved on to task 3. I had very minimal experience with building and uploading network services and virtual network functions, so I took it upon myself to attempt a couple different options with OSM here. It was able to successfully build and upload the packages, and here I was able to validate them as well, just for extra careful or extra care here. For tasks 4 and 6, we had this morning some last-minute fatal performance issues where it seemed like the memory was being eaten up on our server. So this is the screenshot of me trying to pull a Juju status and getting nothing, seeing who else is on the server, and then actually asking who's on the server so that I could try and reboot them. So we did actually successfully reboot the server, and it freed up a huge amount of memory. So it lasted for a little bit, but then services started spinning up again, and that was just not very conducive to trying to finish anything this morning. Task 5, we were able to define scaling. So on the Gnode B, as was the example given to us, my screenshot basically just gives you the scale 2, but we were not able to trigger the actual scaling. So it was set up, but it was not triggered. So we had some lessons learned here. One of them was communication. Early on in using Slack, we had some asynchronous communication issues, and of course, we're all in different time zones. So part of our team is in Europe, and part of them is on the other side of the world from us. So we had some time spent catching up with that. The documentation, we lost out on recording a lot of our documentation for the tasks that were completed, thus missing out on some screenshots that I would have loved to have had. I did try to recoup some of them this morning. So some of them, if you go back and look at the timestamps, you'll realize were before the meeting was taking place today. We ran into some known bugs. Multiple teams ran into some known bugs, and I'm really happy that the teams are super on top of that and able to point that out right away. And I also do enjoy Slack because I was able to search through other chats to find where other people had come across these same bugs. There were also some unknown bugs that we thank you very much to the team for, not our team, but like the team from OSM for being able to correct that, publish it out in the Git repo, and just have us pull that down again. So that was great troubleshooting and bug fix right on the fly. So that was really nice to see, and we thank you for that. And of course, the last thing was the server performance. Either because of something we did or just in general, performance this morning just kind of slowed down, and it's all right. We got through what we essentially wanted to get through, and we made some progress edgewise that you're going to hear about from our professor in just a moment. But thank you to all the mentors, everybody from OSM and the vendors, and thank you to all the teams and team members. I personally had a really great learning experience with this, and I'm sure my colleagues did as well. So at this point, I'm going to turn over to Professor Colini for a demo. So I'm just going to stop sharing my screen, at least I'm going to right here. And you can go ahead and hand that over to the professor if he should be in here.
Okay.
Would be Hisham.
Hisham,
Yeah.
Okay, let me find you. Yeah, there you are. There you go.
Okay. Well, can you see my screen?
Yes.
Yes.
Okay, great. Okay. Well, good afternoon, everyone. I think the time now in France is afternoon. Actually, I'm going to introduce today one of the security experiments that I actually found very interesting, and we use this experiment to replace task 4 and 6. We use this time actually to do this security work and the security deployment. So just before I explain the tools that we have already used in this task, I would like just to quickly introduce the security infrastructure that we are using and why we actually implemented this security experiment, because actually we need for this experiment for our deployment here. So this is our security system or security deployment of our security framework components. And as you can see here, there are 4 components actually. One of the major components here is the OSM. So you can see here the OSM component. And then we have another component, which is the radio access network. We use the FlexRAN to simulate the actual radio access network, and we connect it to the E node B and the EG node. And then we have the third component, which is the security component here. And the last component is the machine learning and deep learning model here. So this model is actually a real-time model for 5G network. So what we are trying to do here is to secure the 5G resources. And this is actually part of our Air Force Research Lab collaboration project here in New York. And the OSM system actually is used to orchestrate the services. So just I will give a simple example for what we are doing here, and then I will go to the security tools that we have used and security experiments. So the basic idea here, when you submit a request to the 5G network, like let's say that you are trying to download a large video, okay? So the OSM system here is used to orchestrate the services. So it is used actually to initiate the slices, and each of these slices has some resources which will be used actually to download and show the video that the user is asking for, okay? And here, when the user submits a request, this request is sent using the .json format. So the .json format, the .json template here is used actually to define the hardware that the OSM system and the FlexRAN will use, both of them. It's something similar to the YAML template, okay? And using this format, we actually abstract the infrastructure. So we use the same template here. So if we change this FlexRAN or whatever systems that we will use for the radio access network, the system will not be changed. So the system is abstracted regardless of the underlying infrastructure. And when you submit any of these tasks, the OSM system will find the suitable resources to run this task. And then before the OSM system orchestrates these services and uses the resources, the OSM system asks our security framework to first to define how whether these resources are secured or not. If these resources are under attack, then the security system will ask OSM system to block these resources and to exclude any slices that were initiated using these resources. So in this way, we will make sure that the resources that you are using and the slices that the OSM system initiated are secure. And from this point, actually, this is the one of the goals of the security experiments that we have run. So here, how can we define that these resources are secure? So what we actually did, we analyze the TCP dump data, and we forward this TCP dump data to the Wireshark. Of course, later on, we will extend this experiment, so we will forward the TCP dump data to Snort system, to other intrusion detection systems, and just we will like extend the experiment a little bit. So what we did, first we run the distributed denial of service attack using the LOIC tool, LOIC tool. So the LOIC tool is used to run the distributed denial of service attack against the OSM resources here. And then after that, we collected the TCP dump data, and we forwarded the TCP dump data to the Wireshark to analyze this traffic, to decide how whether any of this traffic contains a signature for the DDoS attack or not. Okay, so this is the big picture of what we actually were doing. So now, in order to do this, actually there are a lot of resources that were really very valuable in this event that we have already used, like the introduction to the Kubernetes and the way that tools or components are connected to each other, as David explained to me before, using the links. And then we started actually to find some security tools that can work with OSM system, because actually the security part in OSM is really missing. There are a lot of work are currently going to improve the security part of the OSM system. So what we did actually is that we used the KSNAVE as a Kubernetes integrated packet sniffer. So we linked this tool with the Kubernetes and the clusters, and then we forward the traffic to Wireshark. So the KSNAVE here is shipped as QPictel. The QPictel is this is the Kubernetes tool, and Kubectl plugin actually allows using the TCP dump and Wireshark actually to capture the traffic on a specific boot within a cluster. And since the current available tool actually are missing such kind of security analysis, so we try to link these tools and to end with something I think a little bit interesting about these tools. So the question here was that do we get to inspect this traffic? So how can we inspect this traffic, and how can we forward this traffic to a certain instance or outside the environment? So this is the question that actually we are going to answer here in this slide. So remember, the main goal was to analyze the traffic, to decide whether there are any attacks within this traffic, and then based on this, we will decide whether the resources will be used or not. But in this tool, I'm going to show how did we analyze this traffic. So using the KSniff as a Kubernetes integrated packet sniffer, we actually use it to upload the TCP dump binary packet sniffer to the target container, and then we redirect the output to the Wireshark instance running in my machine, and actually this idea of forwarding this traffic to an external machine was coming from Indica, from the OSM team, and thanks to Indica for this. And then what we did actually is that we first tried to run the Wireshark at the .39 machine, but the graphical user interface is not enabled there. So I tried the VNC to access this machine, but couldn't actually show it. So I forwarded the traffic to Wireshark according to Indica advice. So, and then maybe you may think right now, how would this work in container without explicit network capabilities or non-privileged users? And this is also another important question. So here, the KSniff actually has a specific flag, the -p flag, and this approach actually can help us to, or can be used to sniff the traffic in a distroless container. The distroless container here, it is one type of containers where the binary cannot be executed by a shell, and this is why the task is not easy. So here the binary cannot be executed by the shell, so you have to forward this to another central management system where you analyze this traffic. So yeah, just to make long story short, I will just quickly through the processes and the commands, and I have put screenshots here, and there are all these tools are installed in .39, the boot and everything, the deployed application, everything is installed there. So I will just quickly go through these tools here. So the first step for us, we install the Falco software, which is an open source runtime security tool. And we use Falco here actually in our experiment to do what? To generate traffic. So we use this tool actually to generate the traffic, and we use it also to test and to parse the Linux system calls from the kernel at runtime, from the kernel perspective at runtime, and then we run some powerful rule engine and using the Falco tool, and then when there is any rules are violated using the signature-based detection, then the alert will be fired. Okay, and then the next step, we install the crew. Crew, I think some of you knows crew. Crew is a tool actually which is used to make the Kubectl plugins easy to use. So it helps you actually to install and manage some plugins, and it is very similar to the app, like when you use the apt install or the DNF or Pro. So here in this side of the virtualization environment, the crew is used to do these tasks. So then after we install crew, we actually install crew to run the sniff and the key sniff tool. We cannot run the sniff or key sniff tool without installing the crew, which works with the Copectel plugins. And then after we install the sniff and key sniff tool here, we capture the traffic on a specific boot within the cluster. And then we use the Copectel to upload the TCP dump data binary file, okay, to the target container. And we redirect the output to Wireshark instances. And after that, we install the live cap diff, which is used actually to compile the TCP dump data to generate the binary files. Because as I explained before, you cannot analyze this using the traditional tools, using the binary files at the same site. So we generate the binary file, and then we forward the binary file to Wireshark to analyze. And then we install the LOIC. LOIC, it is the low orbit tool to run the distributed denial of service attack, the DDoS attack. And after that, we installed Wireshark just to analyze this traffic. And then this is the sequence of the processes. So we install Falco and then crew to run key sniff. And after we run the key sniff, we run the attack against the infrastructure using the LOIC. And after that, we capture the TCP dump data using the live cap, and we forward this traffic to Wireshark. So these are exactly the processes that we run, and these are the processes that I'm going actually to show also here. So the first step here is to install Falco. So we install Falco here. So here and here. So here we completed the installation of the Falco. Okay. And next step for us was to install the crew. So we install crew using this set of commands, using the get command. So we run this, and then crew is installed successfully. And after we install crew, and remember, we install crew, why? Because we need crew actually to run the key sniff and the sniff tools, okay? To run these plugins. Then we install the sniff. Sometimes they call it sniff or key sniff, okay? So according to some versions of Linux. So the sniff here is installed using the crew, as you can see here. So using the Copectel plugin, we use the crew to install the sniff, okay? And then after we install the sniff, as you can see here, okay, the sniff was running successfully. And then we started actually here to run the live cap to install the compiler of the TCP dump data, okay? And then after we install the live cap, we actually run through the TCP dump compilation here, as you can see. And after that, we actually started to run and forward the traffic to the Wireshark. So here we have to define two things. First, what is the boot that we are using? And so this is the boot that we were using, which is currently available at .39. Okay, and then we define the available nodes. So this is the available nodes that we use. Okay. So we get this using the micro 8's Copectel get nodes, and then the Copectel deployment. So this is the current deployment here. Okay. So this means what? This means that using this task, which is currently deployed here, which is boot camp, which is generated also from Falco, we generate this traffic using this one, and this traffic is going actually with this boot, and the traffic in this boot is forwarded to Wireshark. So this is the sequence actually, okay? And then after that, we use the LOIC. This is the LOIC tool to run the DDoS attack. And then after that, we run the wireless, the Wireshark analysis. And here the problem that we faced actually was that we couldn't analyze this traffic, okay? Or we couldn't run the Wireshark at the machine because the graphical user interface was not enabled. So I forward on this traffic to another external machines to run and to analyze this traffic, and we get here the traffic which has some signatures from the distributed denial of service attacks is actually labeled here with the red color, as you can see here. Okay, and yeah, that's all what I have. Yeah, so yeah, I just would like to thank you guys for your help. I would like to thank Sylvia, Masij. You asked or you suggested me to and my team to collaborate with your team later on, with the OSM team and with the OAI team, and we really appreciate this. Thanks to David who explained to me how these components are linked to each other, and thanks to India who also explained to me how can we forward this to external machine just to show some traffic. Yeah.
Okay, thank you. Do we have questions for Team Sanipoli?
So I have a couple of questions. So if you go back to the last slide, how did you detect it's an attack? At that part I could not get. So you shipped it to the Wireshark. How did it detect it's an attack? The red, what you highlighted in red?
Okay.
I missed that.
Yeah. Well, can I share my screen here? It's already shared. Okay. Yeah. So if you can see here, yeah, this is exactly what Indica actually helped me to do. Actually, so using the SSH remote captions, you can define the machine where you want the IP address of the machine where you want actually to get the traffic from. So you define the IP, the SSH port, and the traffic. So the traffic will be forwarded to the external environment. So in the Wireshark, you have this option here.
No, how did you find that it's
password back in for it to work? It won't work without, it doesn't save the password between sessions.
Sorry, can I repeat again?
and what is the integration here with open source MANO? Like, did you do any like what I understood was you generated traffic and then you ship it.
Yes, I got what you. I got what. Okay, so let me return back to the figure here, just to explain what is the integration of OSM with what we are doing here. So the OSM here is generating and orchestrating the services using the network slicer, right? So the resources and the traffic which are going here should be captured to be analyzed, and this is what we did. So we analyze the traffic here using this security tool. So OSM or the OSM system here is used actually as an environment which actually generates the security requests. So the security requests of these resources are coming from OSM, and then based on the traffic which is going within the OSM, we define whether this traffic contains some signature from the attacks or not.
Okay, so you modified open source MANO to give a request to a threat engine to analyze the traffic. Is it a correct understanding?
Yeah, using the Kubernetes, we actually get the traffic which is going in the boot system and for the application which are deployed within the boot, as you can see here. So this application, which is Kubernetes boot PAM, this is the application which generates this traffic in this boot, and this is the name of the boot. So you have this boot here, okay, and then you have this application is running there, okay. So when you return back here, so the traffic which is coming from this one is forwarded to Wireshark to analyze. In real time, we don't use Wireshark, of course. In real time, we have to use a real-time intrusion detection system like Snort, like OSIG or OSIM. And this is exactly what we have at our side here. We have OSIM system as a central management system which integrates the alert from host-based intrusion detection system and network-based intrusion detection system. But here, for our experiment, because of the short time, we cannot set up all these systems. So we use Wireshark just to analyze this traffic just quickly. Yeah.
Thank you.
Any more questions?